Welcome to Zeiss Inspect X-Ray. In this video, I'll show you different tools for visual inspections in Zeiss Inspect X-Ray. We'll cover the multi-view, its customization and features, the properties where you can customize the appearance of your volume data, and you'll learn how to construct and inspect elements directly on your volume. If you want to try Zeiss Inspect X-Ray, take a look at the description below. There, you'll find links to download the software, request a free trial, and download training data. To show you the options for visual inspections that Zeiss Inspect X-Ray offers, we'll take a look at a battery. My project contains the measured volume and a part, which contains the linked volume. Whenever you measure or import data, the software automatically creates a part and linked volume. Alright, let's cut to the chase and talk about one of the main features for visual inspections in Zeiss Inspect X-Ray, the multi-view. With the multi-view, you can visualize your volume in both 2D and 3D simultaneously. It allows for easy navigation through the volume and is entirely customizable. I just switched to the orthogonal view, one of our system templates. It shows 3 orthogonal sections of the volume in 2D and the volume in 3D in the bottom right corner. The screen space is divided equally between the 4 quadrants, which makes it easier for you to work with both 2D and 3D data. On the top of each quadrant, you have a small toolbar. If you watched the video Zeiss Inspect X-Ray user interface, most of this will sound familiar, but let's quickly go through the basics. To take a closer look at any one quadrant, you can maximize it and minimize it again. If you take a closer look at the 3D view, you'll notice the section planes X, Y, and Z. They show you which parts of the volume you're currently visualizing in 2D. You can enable and disable them with Show Section Planes in 3D. If the section plane indicators are bothering you in the 2D views because they're overlapping a defect, for example, you can disable them under View, Multi-View, Show Section Plane in 2D. If you want to change the view completely, to take a closer look at a volume defect, for example, you can use Set Focus Point. The view in all 4 quadrants is automatically adjusted to display the newly set focus point. To navigate through the volume, you can use Alt and the mouse wheel. To increase the interval size, use Alt, Shift, and the mouse wheel. Alternatively, you can drag the axis in the section views to another position. And with Alt-R, you can center all quadrants on the volume, in case you moved it out of view, for example. So much for the basics. If you watched the video Zeiss Inspect X-Ray user interface, you might also remember that you can customize the multi-view. Just a short reminder, you can choose one of the system templates here, or create your own by selecting Layout Template. Before I show you how to use the multi-view to create inspections, I want to talk about the properties. In the properties, you can change the display settings of your volume. The tab Display is divided into Volume and Volume Slices. The settings under Volume impact the 3D view. The settings under Volume Slice change the 3 section views. Let's take a look at the tab Volume first. Here you see a histogram showing the distribution of voxels over gray values. At the moment, everything is gray, but you can change that, either manually by selecting a range in the histogram and choosing a color here, or by choosing a color template down here. You can modify the template and add a color, for example, or delete one you don't need. You can also change the opacity for each color range. The higher the horizontal line, the opaquer the volume range. You can also display a color gradient instead of color ranges. The customization options remain the same. Beneath Color Template, you can change the render quality from standard to low if your computer is struggling, for example. Now the last parameter, absorption length, impacts the opacity settings in the histogram. It's the distance over which the X-ray beam is absorbed. A high value here means that this part would remain somewhat transparent, even if I set the material indicator to opaque, because the material isn't as thick. So much for the visualization in 3D. Now let's talk about volume slices. Again, you have a histogram here. You can change the contrast by moving the material indicators. You can use a color template or choose custom colors. I'll use the template Gree3 Materials Matte. Before we continue with visual inspections, let's create an alignment. If you look at the coordinate cube in the corner of the 3D view, you'll see that the volume is currently not aligned within the global coordinate system. That's also noticeable in the section views and makes navigating through the volume more difficult. That's why we recommend creating an alignment. I want to show you how to create a manual alignment using the function setMatrix. To do that, open Operations, Alignment, Manual Alignment, setMatrix. This function allows you to rotate and translate your part. But the reason we're using this manual alignment here is because of its intuitive handling in combination with the multi-view. By default, the option Set Transformation in Section Views is active. That means you can simply adjust the position of your part in the 3 section views and use the grid as your guide. As you can see, the actual data is now aligned within the global coordinate system, which means you can use the coordinate system to move and rotate the volume. To create the alignment, click OK. Quick and easy, isn't it? You can find the alignment in the Explorer under the part. Alright, now let's get back to the multi-view. So far, we only talked about visualizing the volume and defects, but what if you want to perform inspections? That's possible too. I want to show you how easy it is to measure the overhang of the layers in the battery and the size of a defect. Let's start with the overhang. When I zoom in here, you see the anode and the cathode. We want to measure the distance of the overhang. I'll use Set Focus Point so all views are centered on this position here. Next, I'll configure the volumetric sampling. When you activate volumetric sampling, the software doesn't just use the data of the selected section, but in this case, an average of the sampling range. The size of the sampling range is indicated by the dotted red lines in the other 2 section views. I'll set the sampling range to 0.335 millimeters. To better illustrate what volumetric sampling does, let me turn it on and off. As you can see, when volumetric sampling is disabled, the image is noisier. We want to measure the distance here. I'll quickly turn off the axis indicators because they're in the way. Then open Construct, Distance, 2-point distance. Use Ctrl and the left mouse button to create a point on the anode and another one on the cathode. There are 2 different ways of measuring the distance, either from the tip of the anode to the tip of the cathode, or by mapping the tip of the cathode onto the anode. If you want to change the position of the points, you can simply drag and drop them to the new position. Then click Create and Close. And here's the measured distance. If you look at the 3D view, you can see the distance relative to the entire part in 3D. And you can find the element in the Explorer under Actual Elements, Dimensions, Distances. If you want to add tolerances or restrict the check to a certain direction, you need to apply a check to the element. To do that, open iInspect either in the main toolbar or with Ctrl and the right mouse button. Then open Check and select the one you want to use. If you ever need to change an element, simply select it and press F4, or click the right mouse button and select Edit Creation Parameters. Make whatever changes necessary and then click OK. You can change any element at any time, including fundamental ones like alignments, for example. The software automatically keeps track of all dependencies and recomputes all dependent elements, checks, and even report pages. Please note that you need a Pro license to use edit creation parameters. Now I want to show you how to check a volume defect. I'll adjust the section view Y because I noted down the position of a volume defect, and then I set the focus point so you can see it in all 3 section views. For section view X, the volumetric sampling is still active. Remember, we used it for the distance check. When you're looking for volume defects, it's best to disable volumetric sampling to see them more clearly. To measure the area of the volume defect, we'll construct and check a polyline. Open Construct, Curve, Curve Polyline. Then use Ctrl and the left mouse button to trace the curve. If you're unfamiliar with the mouse commands for a specific function, take a look at the tooltip in the 3D view. Then click Create and Close. Now all we need to do is check the element. Open iInspect, either in the main toolbar, or use Ctrl and the right mouse button and place it anywhere. The functionalities that are available in iInspect depend on the element you selected. In this case, we want to check the curve, so open Check and select the check area. I simply want to measure the area of the volume defect, so I don't need any tolerances. Click OK to create the check, and here's the result. You can find the curve and the check under your part. The curve is under Actual Elements, Geometries, Curves. The check is stored under Inspection, Dimensions, Dimensions, Scalar. Now let me mention one more thing. If you want to save a particular section, because you can see a volume defect well, or because there are other interesting features, you can use any of the section views to create a section. Simply click Create Visualized Element Sections. The software then creates a section for all the elements that are visible in the section view. In this case, it created a volume section because I'm only displaying the volume data. You can find the volume section in the Explorer and drag and drop it into the multi-view if you want to view it again. If you want to document your results, simply click Create Report Page in the main toolbar. SeisInspect X-Ray offers special report templates for volume inspection. Let's use Quad View. If you want to adjust the position of the content or labels, click Edit Content. So much for this introduction to visual inspections, but I only scratched the surface in this video. There are so many options and different use cases for visual inspections on volume data. So give it a try and see what works best for your applications. If you're looking for a more comprehensive training, check out the Inspect X-Ray Basic e-learning. You'll find the link in the description below.